Hello, everyone. Thank you again for attending today's webinar, Getting Ready for Field Season. A bit of housekeeping before we get started. We will be making this webinar available on our YouTube channel. Please leave any questions you have in the provided questions field, and we will get with you afterwards to answer those. My name is John Florio. I work here at Juniper Systems as a product manager. And I'm going to be working today in this webinar with Trevor Brown. He's one of our business development managers. So Juniper Systems, we're a premier manufacturer of rugged field computing solutions. We also make harvest data collection systems and various sensors. Our products are designed and assembled right here at our facility. We maintain a 90,000 square foot facility here in Logan, Utah. All Juniper Systems branded products are built right here in Logan. We do all the design, engineering, and manufacturing and assembly right here. We serve a diverse group of markets. The common need for those markets is reliability. And we strive to focus on having the lowest warranty failure rate in the industry. Our focus as a business is on quality and service, and we're a ISO 9001 certified facility. Okay, so why are we here? We all know the 5 Ps, right? Proper planning prevents poor performance. What we want to go over is some tips that's going to help you to start off your season right. We want to give you information that's going to help you to get ready and prepare for the upcoming field season this year. But remember, use what works best for you and your team. Now, you saw that picture of our building. Great picture, but this is what it looks like today. This is why we're talking about this subject today. We probably won't be outside mapping. The weather is a little chilly. You may have heard recently in the news this week about a place nearby called Peter Sinks, where the temperature dropped down to -62 Fahrenheit or 52 Celsius. So it's a little early in a new year, so this is a good time for all of us to get together and think about the year ahead, at least here in North America, and how we'll get our projects done. All right, first things first. I want to talk about safety. Remember, safety is an endless task. Always practice safety. Safety is important for you. It's important for your team members, and it's important for your business. So in your field projects, be proactive about safety. Remember, we want everyone to come home alive. We don't want to be like this picture here on the screen. Some quick safety tips. Safety starts with the individual. As my friends over at our office in the UK say, they always say health and safety. They use that phrase a lot when we're setting up at trade shows. Think safety head to toe, from having a hard hat to protect your head from getting bumped, maybe having eye protection or hearing protection, considering the work environment. Make sure you have gloves on if needed, and even think about steel toe boots. Always wear that bright safety vest so you can be seen and be safe. And safety not just for you, the individual, and for your team members. Think about the work environment. Watch for hidden dangers when you're out there doing field data collection. Clearly identify your workspace for you and the public. Use those safety cones. Make sure you wear that vest. And put up some signage. You may be working on a project where you have some uncovered ground and you don't want someone walking into that area. And communicate. Always have safety briefings before you start your project. Make sure you do that every morning before you get running. And regularly check in with your team. We like to say use the buddy system. Your buddies can check in virtually. You can text, you can phone call people. Just remember, when it comes to doing field work, safety is paramount. All right, let's talk about planning. First thing you have to think about is the needs assessment for your project. Do you have a clear definition of the project goals and the project deliverables? Do you have a signed agreement with your client? Do you have a statement of work? And do you have the tools, the team, and the training to accomplish the job? Remember, you want to have a written plan of execution. Don't proceed until all parties are clear and have a defined understanding of what is to be done. Next, you want to assess your gear. Do you have the correct equipment and tools to accomplish the job? You have to define your work system. Now, a work system is what? It's the people, the processes, and the tools that you're going to use to accomplish work. You want to plan out your field data collection system. I'm sure it'd be great to have a nice clean truck like in this picture here, but you'll notice everything has a place and you can find the tools you need. And don't forget, make sure you have spare keys for your vehicle and have plenty of water for your team. All right, what is a field data collection system? Now, besides the people and the processes, we have to think about the tools. And that's what we're going to talk about today. Your field data collection system may include, but it's not limited to, your computer, which could be a tablet or smartphone, your sensor, typically a high accuracy GNSS receiver, your software, which may consist of reference data, different workflows. You have to think about the user interface and storing of that data, but you might also have other tools. You might have other sensors like soil samples or water probes or tree coring tools, maybe animal ID tags, even a camera or a tape measure. And always carry a backup. It's always good to have in your pocket a notepad and maybe a mechanical pencil. Because in a pinch, you still have your eyes, your brain, and something to capture information with. You can still get work done. Okay, we're going to go into the details of field data collection system, which means the computer, the GNSS sensor, and the software. And I'm going to give you some examples of products that we build. Now here's a picture and some specifications of our Mesa 3. It's a rugged notebook, a rugged tablet, a rugged computer, but this is a bunch of specifications. You don't want to think about specifications alone. You want to think about what problems you're trying to solve. So when you think about the specs of a product you're looking for to use to do your job, don't think about what operating system it has just as a specification, but think in terms of, can the operating system run my target apps? Can I work all day without power? Thinking about batteries. What about the display? Can you read the screen outside in sunlight, even with your sunglasses on? For example, the Mesa 3 has what's called a circular polarized display, which allows you to use it in any orientation. You can still see the screen, even with polarized sunglasses. How rugged is the product you're going to use? In other words, in your work environment, you don't have to worry if it rains or if the product gets dropped in a puddle or gets wet or some mud gets on it. What about connectivity? The Mesa 3, as an example, has Wi-Fi, Bluetooth, and even cell modem options. So can you connect to your GNSS receiver without using cables? And can you connect to the internet in the field to download or upload data if needed? Maybe you're using an application that has real-time maps. And then think about the other features you might want on a product. Do you need to be able to capture photographs and attach that with your data? And do you need to video conference with team members? And even thinking in terms of backing up your data. Do you have the ability to simply plug in a USB drive and make a quick copy? Maybe something happens and you want to make sure that you have an extra set of that data, because the work you're doing may be time critical. It may be information critical. The information you're capturing and the work you're being paid to do could be very expensive, and it may be only one time you can capture that information. You want to make sure you have a good backup of that data. So the Mesa 3 is one example of a rugged handheld product with a 7-inch display. It's big enough to see things on the screen. It's small enough to carry easily in your hands. What if you want to see things on a bigger screen? We also have the Mesa Pro. The things I'd mention here is it's a larger display, so that allows you to view more information on the screen. It's also a higher resolution display. And remember, this is a Windows 11 computer, so it's a full office in the field. You can run all of your desktop apps. You can run high-end apps. Not only could you maybe be using a mobile data collection app, but you could even open up ArcGIS Pro, for example, or maybe you're running some other product that's going to give you all the information you need to see in a field. It does have a bright daylight display and an active touchscreen, just like our Mesa 3, and it has all the other features that will probably meet your needs for outdoor field work. What about your sensor? Well, we make a product called the GNSS 3. This is the newest version of our Geo line of products. It's a high accuracy mapping grade GNSS receiver. It has a new receiver engine, which supports more signals and channels than the previous versions of the product, which allows us to offer it in single and multi-frequency models. It does have now scalable accuracy. You can configure it for sub-meter, sub-foot, or even decimeter work down to 4 inches or 8 centimeters. It does that by support for Atlas L-band corrections. It also has an updated design to make it even more rugged than the previous versions of the product. Now, we think about the user when we build our products. A nice feature of this product is it's simple. It's easy to use. It has one button and a small array of LEDs that are very easy to understand to see what the receiver is doing. It's designed to be easy to use in the field. And it's compatible with pretty much any mapping app that you might use, such as Esri Field Maps or Survey 123, or maybe you're using Mergent Maps or a global mapper product. Even our Uinta field data collection software works fine with that too. Along with the geode, we provide a simple utility. This is something to think about too. When you're choosing a product, you want to make sure that the product will do the job, but the product is also supported in some way. The Geode Connect software we give you is a free utility that's available through app stores and through our website. But it's not required to use a product. What it does do is it gives you the ability to change settings as needed, select different correction services, and it can function as an interface for those corrections and an interface to other applications where needed, maybe on Android or providing virtual COM ports on a Windows device. It also works with iOS products such as iPhones and iPads. Now, I mentioned that we have 2 different models of the product. We have a single frequency model, the GNS3S, which replaced the previous GNS2. And that can use SBAS or NTRIP to get you a sub-meter solution. And we have the GNS3M, which is the multi-frequency model of the product. Having multi-frequency allows us to use more corrections and to support the Atlas L-band corrections, which will give you accuracies in the sub-foot or decimeter range. So how does it do that? We use different corrections. So let's talk about some of those correction services, what they are, and how to choose the best correction service for your needs. So right out of the box, every geode, regardless of its configuration, will work with SBAS. SBAS means satellite-based augmentation system. This is a regional correction service that reduces the biggest source of error in GNSS error sources that a receiver may experience, and it reduces the ionospheric error. It can take the standard GNSS receiver, which has an autonomous position accuracy of maybe 3 to 5 meters. In the case of the geode autonomous, maybe it's 1.5 meters or so. And by applying the SBAS corrections, you can get it down to sub-meter. Just like in this image, you can realize a point on the ground that's maybe no more than 60 centimeters in error. Some challenges you need to remember, though, is that it uses geosynchronous satellites, and these can be blocked by terrain. And with SBAS, you have limited coverage areas. Now, when I say limited, I mean large parts of the world, continental coverage, but not everywhere in the world. And again, it only covers ionospheric errors, so that's what limits it to sub-meter accuracy. Here's a quick map for you to see of the coverage areas for SBAS. We have WAS in North America and EGNOS in Europe. And then over India, there's the newer Gaganyaan service and MSAS, which is now being broadcast by one of the QZSS satellites in Japan, which covers much of Asia. And then the newest service that's available is called SouthPan, and that's for covering areas around Australia and New Zealand. It's not fully active yet, but it is in as-is mode, and it does work. And you're going to see more features come from that service soon. Okay, what if you want a little bit more accuracy? Let's take a look at the dots on around the feet of this operator here in the field. I'm sure everyone would like a nice open working environment like this, but maybe not with all that snow. It's a little chilly. The benefits of NTRIP is it gives you a high amount of real-time accuracy. You get very fast solutions. Initially, it'll resolve a solution in less than a minute, and it's a local correction service that is provided over the internet. It's available in most populated areas. NTRIP is the internet delivery method for RTK corrections that a geode can use to calculate a real-time differential GNSS solution. The challenge you have to think about is that the coverage varies depending on where you are in the world. The coverage is generally associated with populated areas, and it does require continuous cellular data connection to work. You also have to think in terms of operational cost. In some areas, N-trip is free. In other areas, it could be $400 a year. It could be up to $2,000 a year. It depends on the provider. The other thing you have to be conscious of is that generally, RTK course networks work in the national standard for where those networks are organized. So for example, here in the United States, the standard for the datum or model of the Earth is North American Datum 1983, and currently we're under APOC 2011. Now that's different than the datum, the reference system that GNSS works on, which would be WGS 84. In fact, right here in Utah where we're located, you could be talking about more than a 4-foot separation between those two datum examples looking at the same coordinate value. So you can see a position shift of over 4 feet if you're not paying attention to the projections in your mapping system along with the correction service you're using. Just something to take note of and watch out for. Okay, what else can we offer? We also have this newest correction service available with the GNS3, which is called Atlas. Atlas is a satellite-based correction service, which means it has worldwide coverage. It also has multiple accuracy levels. You can have an accuracy like these different circles here in the example in the image of 50 centimeters with Atlas Basic, or 30 centimeters with Atlas H30, or 8 centimeters with Atlas H10. It can also tolerate interruptions once convergence is achieved, as long as it's able to reacquire signal from time to time. It's a great solution that allows you to purchase the accuracy you need for the amount of time you need to use it for the length of your project. And it's an excellent solution if you're in an area where you're very remote and you don't have any other coverage solution. Some challenges you need to think about, though, is it is broadcast by geosynchronous satellites. So just like SBAS, it can be blocked by terrain, depending upon your orientation. Maybe mountains, maybe trees or buildings around you. You have to think about that. And it has longer convergence times, which convergence is the time it takes to resolve a solution. And you have to take that into account on your project. So here's an example of where Atlas works. It covers most of the Earth, not the entire Earth, because obviously it's round and we're broadcasting signals from the equator. So at the most northern and most southern latitudes, you're not going to see signal much above 70 degrees north or south. And it is a terrestrial or land-based service. So it covers all land continentally, and you do get coastal coverage up to 12 miles out or 20 kilometers offshore. It is a paid subscription service with different accuracy levels, and it uses what's called precise point positioning, or PPP. You may see that in different places. So what is PPP? It's the time it takes for a single receiver alone, to model GNSS system errors and to derive an accurate location given precise satellite clock and orbit corrections that are broadcast from a global network of reference stations. Unlike RTK that solves vectors between receivers that are what you might call nearby, say maybe within 20 or 30 miles from each other, PPP allows a single receiver to figure out its solution anywhere it can receive signal over much of the Earth. The thing to know about it is that that ability to figure out an accurate position takes time. So here's an example of the highest accuracy version, say 8 centimeter or better accuracy, the Atlas H10. And this is an example of doing what we call cycle testing to see how long it takes to resolve our accuracy, which is the vertical scale, in 10 centimeter steps here. How long does it take to resolve down to a converged solution? And you can see on the horizontal scale, each line is basically a 5-minute separator. These are seconds along the bottom. And from a factory reset on the receiver, it initially starts acquiring satellites, figures out a basic solution for its position, and then begins to converge. And between 25 and 30 minutes, and we've done several restarts here just to test this, you get down to a 10 centimeter solution or better. 8 centimeters, and you'll see it'll even converge a little bit better than that over time. Now, this doesn't mean you have to be stationary for it to converge. It doesn't mean it needs to converge every time you want to capture a point. It just means it needs to initially converge to come up with a good solution. You don't have to be standing one place. You could take the receiver and mount it on the roof of a vehicle and start driving out to your job site. We've tested that. It takes about the same amount of time. So it is a good solution that you can use. You just have to plan how you use it and work a little bit differently. The recommendations we give to people is turn the receiver on first, then go through the rest of your processes getting ready to start your work. Just to compare, here's some tests we did with Atlas H30, which is our sub-foot solution, and Atlas Basic, which is the sub-meter solution. And you can see that the convergence for Atlas H30 is about 10 or 12 minutes. And for Atlas Basic, here it shows around 7 minutes in these two tests. But remember, these are doing factory default resets each time. In normal field work, you're not going to be doing that. And we found that the normal convergence for Atlas Basic is about 5 minutes or so, the same that you might see with SBAS. Okay, let's wrap that up. How do you choose which correction service do you use? Well, think about the type of work you're doing. If you need sub-meter accuracy at minimal cost, then SBAS is going to be the best choice for you where it's available. If you need a little bit more accuracy and you do have an internet connection, you could use a real-time network and you might be able to get more accurate solutions, better quality data. Just watch out for those data conversions. Now, if you're working somewhere that's very remote and you don't have any other solution, think about Atlas as a possible solution for you. It can give you increased accuracy and it can give you coverage where you don't have any other solution. We just had 2 different customers in 2 different parts of the world. One was in Guam, another one was in Ghana. And in both instances, they didn't have any other correction service available to them, so they used Atlas and they were getting very good data. All right, some other considerations for field work. You have all these pieces and parts. You've got your computer, you've got your GNSS receiver. We're going to talk about software here in a minute, but how are you going to carry these things? How are you going to use them in the field? Well, you want to think about the work environment. Do you need maximum precision? If you do, then think about more traditional methodology of using a fixed type pole or maybe even a collapsible pole and set it up over each point that you need to capture. Maybe even do some averaging so that you get the best possible solution. Maybe you need to cover a lot of area. You need to bring a lot of other equipment with you. A lot of natural resources projects, they may need to bring tools with them and maybe take soil samples or vegetative samples, samples of plants, and capture those so that you might use a backpack. You're going to get sub-meter accuracy for what you're capturing, but you can also carry along all the tools you need. If you want maximum mobility, maybe use a universal mounting tray that we have, and you can attach a smartphone and the geode to this tray and have an all-in-one handheld solution. There's many ways to use these products. We even have a product that allows you to clip the geode to any backpack and have it sit on your shoulder. And remember, when you're capturing data, if the receiver is sitting on your left shoulder in this example and you're standing still, well, the point is where your left heel is. So you can use your workflows and your behavior in the field to get better data. And maybe you're doing some large soil projects or some wetland delineation, and you might want to mount the receiver on an ATV. The options are endless. It's up to you as to how you use it. Just think about that process. One more thing to think about, power management. Some tips about power and charging. Remember to bring all the appropriate chargers for your solution, for your computer, for your GPS receiver. Make sure you have all of the charges for those items and don't mix and match the chargers. You can get into trouble and you can have some problems. It might look like the connector is the same size, but it might have different voltage or different current output. You want to watch out for that. Batteries. Talk about batteries a lot. Make sure you cycle your batteries regularly. Let them discharge and then recharge them. Don't leave the devices constantly topping off, constantly charging, because you're wasting power and you're actually heating the battery where you don't want to. And don't leave the batteries fully depleted, because you get them to a condition that's low where they may not recharge again. The best thing to do with batteries is to cycle them regularly. And if you've completed a project and you've got to put your product away for a while, say it's going to be on the shelf for a few weeks or longer, charge the batteries up to 50%, not fully charged, but 50%. This is the best way to treat things like lithium-ion batteries. And then disconnect the batteries before storing your gear so that those batteries maintain good, healthy condition. All right, I mentioned we're going to talk about software. I'm going to hand it over now to Trevor Brown, who is one of our business development managers. He also functions as a product manager for our Uinta software product. Trevor, go ahead, take it away.
Thanks, everybody. Nice to meet you. And I am Trevor Brown, Uinta software product manager. And this topic, getting ready for the field season, is really relevant right now. We're seeing a lot of customers preparing for the upcoming field season. And with our Uinta software, we do have a Uinta customer success team that are assisting customers to deploy projects and get ready for the field season. So a very relevant webinar topic. The slides that I'm going to cover are not going to necessarily talk about selecting the right software, because ultimately that depends on the needs of the jobs, and there's a lot of good options out there. All of our products are built so that they can be compatible with industry standard software such as Esri and a lot of different apps on the iOS store, and also Google Play, Windows as well. And so we're going to focus today on not necessarily the software selection process, but if you do have questions about what's the right software for the job, we do have a lot of experience here that we're happy to guide you. You know, what we've seen works with some users and not so much for different applications. And so we're happy to help you there. We're always passionate about talking about your specific job, and so do feel free to give us a call, and we're happy to talk through those. So we will talk about getting field readiness, though, from the perspective of our Uinta customer success team. And we're going to review the kind of high-level steps that we do when we're going to help customers get ready. And so first thing, I want to introduce Uinta. If you're not familiar with it, please do have a look at our website. There's a lot of good information about our Uinta software. It's awesome. We've deployed it regularly, like I said, every day. And these are the kind of key items about it. It's meant to be a hassle-free field data collection software. A lot of people ask us about the name as well, and Uinta and how you pronounce it, where it came from. It's named after the Uinta Mountains, which is nearby our factory here in Logan, Utah. But it's a software that's meant to be customized to users' jobs. So you don't have to be a person that writes code. You can create custom projects for your specific workflows and data collection efforts. So it's meant to be customized. It's also a GIS mapping tool that's very easy to use. People that never have mapped anything at all are very successful mapping with a high degree of accuracy, like John was mentioning earlier. And it does have a lot of professional features, though, things like coordinate reference system support, geoid models for accurate engineering elevations and things of that nature. But mainly it's easy to use and easy to train. That's why we love it. That's why a lot of customers love it. But if you want to learn more about it, check out our website. And when you're looking at Uinta, just recognize that it's not just a mobile app that's meant for field data collection. It's actually used in both the office and the field. And there's an optional cloud synchronization that you can use or not use. It just comes with your license. You know, and this typical tasks in the office that people are using it for are to kind of replacing their paper forms to create custom data entry digital forms. They create project templates that reflects their jobs. They're managing projects, importing and exporting data to do things like reporting and sharing of data. Field users are doing some of those same tasks as well, but they're doing the things you would expect, like mapping, collecting data, filling out data entry forms, navigating to assets, and sharing that with other field users. So just know that it's not just a mobile applications, it's also a complete solution for the office and the field. But it also, similar to our hardware, is meant to be compatible with we recognize other software, and we recognize that our users are going to run with their field collected data in a lot of different ways. So it does import common file formats and export common file formats that you would expect in, for example, spatial GIS, but also in a lot of other ways as well. So learn more about it, check out our website, but that's what Uinta is. And what we're going to talk about next is the software readiness. So getting a project ready for a customer that they're going to deploy in the field. These are steps that don't just apply to Uinta. They can be applied to whatever you end up using. But these are the sort of high-level steps that we do here at Juniper Systems. We want to do some validate that hardware setup. A lot of things John was mentioning. We also want to create the project template, make sure that that's stable before it goes out to the field. And we want to consider some, the unexpected with contingency planning and data security, as well as manage the training scenario. So the first major step that we often consider is validation of that hardware setup. And we're talking about some details that often get overlooked. And sometimes these are the things that our customers come to us and say, thank you so much. I was doing something for a year and it was so annoying, and I changed this minor setting in their device, and it removed some of that annoying data collection or inefficiencies there. And so here's a few examples. We want to first validate the software is installed and licensed and make sure that's all works. You want to get to the field and find out that you've got a license problem or things are expiring. That's a hiccup we get calls about, on various different types of software. Other things, this is the one that pops out to me a lot, is that these virtual keyboards. So if people are typing in the field, if they have to do any kind of typing, it's nice if you don't have to switch between alpha and numeric characters. There's little things that you can do to minimize those sort of extra taps that a field user may have to do. And so this is one that's common. We like to see alpha and numeric characters in the same keyboard. It's not always the same for every job, but that's often one that can be quite annoying for field users. We also want to look at display and battery management. It is definitely annoying as a field user if you have a display that's too dim or it sleeps too frequently. Making sure you have a touch profile, like on our Mesa, that, for example, if you're working in a rainy environment, you want to switch it to the rain mode so that your touchscreen actually works. If it's common that your users are wearing gloves, making sure that it's in their glove mode touch profile, so that but basically you just want to align those types of data entry to the environment that you have. Minimizing device password entry. We see this one a lot, where the device goes to sleep, it wakes up, maybe users are prompted to enter a password, and it was probably done that way with good intentions, but in a real world environment, if they're having to enter a password and it's a long password, it can be definitely annoying for those users. But another one that we often look for is physical buttons. Those can be very efficient when used in combination with a touchscreen. Things like showing and hiding the virtual keyboard very quickly, freezing and unfreezing a touchscreen so that you avoid false taps. So if you're mapping something and you're walking through a lot of brush and vegetation, you can freeze that touchscreen so that it keeps mapping, even though you might hit the screen accidentally, and it'll just keep working. But in general, just make sure that your mobile devices are configured to sort of match your environment and are as efficient as possible for your field teams. They'll certainly thank you, and we see that as a very big benefit for a lot of users. Kind of next major step, this is one of the biggest. With Uinta and other software, you can create project templates. So for example, if I'm a utilities mapper, I want to make sure that my utilities template doesn't have a lot of unnecessary things in there, and it actually reflects the type of work that you do. So this is the majority of a lot of upfront work. Make sure that your project templates actually reflect the job you're doing and they are efficient for data entry. And so one of the biggest things we like to do here is we start with the end in mind. So we look at the expected output from field data collection processes. So maybe it's a spreadsheet that's going to be uploaded to another database or provided to an end user. And if you have an example of what the expected output is, it's then very nice to sort of work backwards and make sure that your data entry forms will actually produce that output. So you want to align that to get the expected result. In those data entry forms, we want to also do a lot of things we talked about earlier, but like minimize typing, use select lists wherever possible so that users don't have to type a bunch of text. Use form conditional logic. So this type of feature exists in Uinta very easily, where you can say, so If, for example, repair is required, you can then show and repair required selected as yes, then additional fields are shown related to that repair. But those fields are not shown if if repair required equals no. So a lot of little form logic you can do to sort of make those forms very efficient for data entry. I also want to validate if you have data that you're going to import to your maps or for your data collection efforts. We really want to validate that first to make sure that the data you plan to import is going to work and looks nice. If you have, in Uinta, you can download offline satellite imagery. If somebody's going to be working in a remote environment and you want them to have that, you can make sure they have that in advance of the field. Make sure you do that in advance. If you have sensor inputs that are going to be incorporated to your data, making sure that all works well, and then ultimately just test all that stuff. And we like to do the office field to office workflow test. Simulate the office, simulate the field, and simulate that data coming back to the office, and make sure that that happens in a smooth way, full circle. And validate those results with field users and anybody who's going to receive the data, because ultimately, that's why you're out there doing it. And so once this project is templates are stabilized, you're really in a good position to start with the more fun thing. Here's kind of a quick example. This is a common example for us. We have a customer that comes to us with a paper form. For them, they're just wanting to replace these paper forms and convert those to digital forms. And also these little hand-drawn maps that this customer was doing, this is very easily then turned into a digital map that can then be reused and navigated and revisited. So just kind of a quick visual of a typical scenario that we might encounter with our Uinta software. This next one, contingency planning and data security. This is a step that we call out specifically. Once we have that project template stabilized, we always like to do some contingency planning and identify possible issues and what our team's response will be to those issues. So if you're dependent on internet connection for your data collection, just determining what you will do if that internet connection fails, for example, or is poor in the environment you're going to be working in, and what your backup plan is going to be. Plan for the potential for device failures. We build our devices ultra rugged and very high quality, but they are electronics, and if you're using other types of devices, it may happen even more frequently. But you want to make sure, what happens if your device has an issue? Maybe you have a backup device, those types of scenarios. Field battery charge options. If somebody forgets to charge their device, what are you going to do? You have some other charge scenario that you can help them get through their day. So identify those issues. You'll be happy you did. Data security and backup. This is one that's really critical. I mean, we spend a lot of effort to prepare for these field data collection efforts, and there's things you can do to secure that data and make sure that your resource, time, and investment is preserved. And for example, you can use cloud synchronization. But I also like to do a little bit of the old style export of your project data with a date, a version, and back that up on something tangible, just in case you lose your device or those types of things, and do that at a frequency to make sure that you can quickly recover as needed. And then lastly, who's the point of contact for any issues? Who are you going to call? And definitely, with us, that you can always call Juniper Systems for questions with your hardware, software. We do maintain staff to be available to assist you real time in the field. So that's something we're proud of around here. So. All right. And the last part we always think of as amongst the most fun is get our users trained once those templates are stabilized. In the case of Uinta, once you have your project template stabilized, it's very easy to train. Common questions and considerations is, how are you going to do your training? Increasingly, a lot of training is done remote. We've got cameras, people can see what you're doing and get that sort of in-person experience. However, nothing can replace in-person training if it's possible or if it's required for your situation. So you got to consider that. We always like to identify who sort of is a super user as well that's available or can help train other issues. So who sort of is the on-site expert that can be an initial reference so that you sort of minimize downtime if possible. We mentioned this before, but we always like to do this field office workflow training. So whenever we do train, we just like to make sure and recognize that it's not just the field data collection that's dependent and needs to be successful, but it's the other people who are dependent on that data as well. And this last bullet, this is a little bit, this is definitely one of the most important things when we do a training. We recommend that hands-on training where possible versus users watching you do something that you have tested and are very familiar with. The ultimate success on our side is when we see field users actually do that process themselves and able to be successful. So be careful trying to show them everything. Ultimately, if they can show you they're successful, then that certainly is the best scenario. And that's all I had for software readiness. Certainly, there's some details that we do as well. That and depending on your job, you may have questions. Feel free to contact us here, and we'd be happy to help guide you and from the experiences that we've learned in talking to a lot of different customers. All right, I'll turn it back over to John. He was going to come at you with some final thoughts.
Thanks, Trevor. All right, just a few more things to think about. Troubleshooting. Now, we've talked about your field data collection system. We talked about the process you want to follow, good things you can do to make sure everything's going to work all right. But eventually, you get out in the field and something happens. Don't panic. Just be ready for the unexpected. But from what we've found, we have a customer tech support team here, and we deal with folks from all over the world who are trying to use our products in all sorts of ways. Here's the most common problems that they run into. It's maybe a battery or power problem, or something with app settings. Their settings are not quite right, not configured right, or their device configuration isn't correct, or they may have forgotten a password or a login, or maybe you have a team of workers and one of those employees is sick for the day or can't be there, and someone else needs to take on the job, and they don't have the passwords or the logins. So most of the problems that we see are very common problems. They're mostly human factor problems, and they are addressable. You can fix them. And then lastly, a lot of these do come down to training, and that's what Trevor focused on there, making sure that you practice. You know what you're going to do before you get onto the field. So when you get there, you focus on the data you're trying to capture, not the tools you're using to capture the data. I guess that's probably the main point to talk about there. But just be ready to troubleshoot and think about those things you're going to have to cover. I do strongly suggest that the crew chief or the team leader, or at least someone in the office for a business, make sure you have those passwords and logins recorded somewhere safe and secure, but accessible in case you need to get to those and you need to make a quick response in the field. And on that note, I would say, have a checklist. This picture here is a picture of a train in Japan. This is something you see in Japan. It's called point and say, or point and call. It's a process they use to ensure that the operators are following instructions for the very next step of a critical task that has to happen. They point out what they're doing and they say it out loud verbally to confirm that they have done the job correctly. So make a checklist. Have a checklist ready for you to go into the field. Do you have your project definition done? Is your equipment prepared? Are the batteries charged? Is your software configured correctly? Do you have the templates created if you have a template-based application? Have you done your dry run test? Has that been completed? Is the team fully trained, meaning they know what to do when they know how to get the job done when they're out in the field? Do you have a record of those passwords and those logins? And again, have you checked to make sure everything's charged up? We all do it. It's going to happen to everyone, but just plan for that and be ready to respond. So in closing, we just like to think of ourselves as your partners. We want you to be successful. Remember, you always have two teams to rely on to help you out. That's your local dealer. They're the professionals. They provide you with the tools you need. They're also your local source for quality support. They can get you up and running. They know who you are. They know what your needs are. But they also can fall back on us, and you can fall back on us too. Here at Juniper Systems, we have the products, we have the personnel. We build the products that you're using. We also have the support and services there to help you get running and to back up those dealers. Just make sure that you have that information so you can access your dealer, access us when needed. Just remember, we're your backup to the dealer and to you. And we thank you for attending and taking time to allow us to go over this information. I hope it's been helpful. And now we're just going to review and open it up to questions and see if there's any questions we have out there. Let me just pull up the list here, and Trevor, I'll try to take these. Let's see. Oh, here's one. Someone asked, how is Juniper preparing for the modernized NSRS, the National Spatial Reference System? Here in the United States, we're going to soon update our spatial reference system. I mentioned that datum, North American datum in 1983. Well, that's going to go away and be replaced by the North American Terrestrial Reference Frame 2022, which will go active probably in 2025. It's an interesting quirk as to how this is done. They measure and determine the best model of the Earth, and then they publish these references. Well, on the receiver side, the receiver functions globally, so it's still going to be WGS84. It's still an ellipsoid model. But on the software side, we will update the projection models in our Uinta software to account for these new projections, these new spatial reference systems, including things like new state plane coordinate systems. If I recall, the same process is happening in the European Union. There's a new spatial reference system that's being done for Europe, and then the countries in Europe will apply that to their national systems and then apply that to their local grid systems. And we will be updating our software to take account of that, as will all of the other major software vendors that you may deal with. They have solutions for that also. It's a normal process of the life cycle of managing a product. Let's see here. We have another question. Let's pull that up. Trevor, maybe you want to answer this. What about making changes in the field? What if you've created a template, but you want to change what you have some new things? I'm trying to read it here. What if I want to add new fields to my data?
Oh, yeah. It's going to depend on your software and its capabilities. In Uinta, you can create in your project templates, you have different fields for data entry. But imagine something like a drop-down list and you want to add a value. There's certain settings that you can do in your project, and this is the types of things you prepare for, where users can add or change data, where you allow them to do that themselves or add those fields directly in the field in your template. There's also an option to sort of lock that template down in certain areas to make sure that users in the field are not doing that. So it kind of depends on your data collection scenario. Within Uinta, you do have the ability to allow users to modify that template directly in the field, where they can add or take away fields, or add the things, for example, in that drop-down list that maybe weren't there previously. So that's actually a good question, because sometimes, if a certain items, small things like that can sometimes stop a field team if you empower them to sort of make those changes themselves, then they can kind of keep moving and they'll have less dependency back on some sort of master template designer. So good question.
All right. If anyone else has any questions, they can enter those into the chat. Let's take a look here. Oh, here's one. Okay. If I'm not wrong, the GPS has no coverage in South America. What are the options for that region? That's a good question. South America is challenging for GNSS for a number of reasons. There's a thing called scintillation, which causes more error that people have to deal with. But as far as correction services, you have areas that have a lot of less populations. So often what we'll see is someone needs some sort of correction service, and we've seen Atlas as a good solution for that area. It does cover all of the continent, and it does give you different accuracy options to use. So that's probably a solution I would use in that instance. Now, we didn't talk about post-processing. We talked about real-time correction methodologies, and there's still post-processing solutions out there. One example is a product from a company called OnPause. They have their OnPause Mobile and OnPause Collect software, and they can capture data and then post-process that GNSS data against base station data later. That's another fallback or another approach that you can use. All right, let's see what else we have here. One more question. Any breakdown for percent of people using single frequency versus multi-frequency or the full GNSS? That's a good question. I'll answer this one. It does vary depending upon what part of the world you're talking about, and it varies on the type of work people are doing. We're still seeing about a 60% user base using single frequency solutions because that allows them to achieve a sub-meter solution. It gets them what they need, but we are definitely seeing a trend where more people are moving to multi-frequency receivers because that opens up the opportunities for additional correction services and additional accuracies. So I expect the trend is going to continue to move in that direction. At some point, multi-frequency will be pretty much ubiquitous with GNSS receivers because of all the new correction options that are coming online, becoming available for people. All right, let's scroll down here. Let's see if we have any more. A couple thank yous here. Thank you folks for attending. Appreciate that. I don't have any in here right now, so I think looking at the time, we're about out of time here, so it's a good time to wrap up the webinar. Any final thoughts, Trevor?
No, I appreciate everybody's attendance, and thank you, and good luck in your readiness for your upcoming field season.
Yes, thank you, everybody. We appreciate you attending. If you have any additional questions, go ahead and put them in the chat, and we will address you offline and respond to you by email. We will be making the webinar available on our YouTube channel, and you can also find lots of additional information there about our products or services, and even information about our partners. So thank you, everyone, for attending, and keep watching for additional webinars as we go through the year to help you get your field work done and be successful in your projects. Thank you very much, and have a great day.